Okay, students, now we'll talk about the work done by non-conservative force. This is in page number 241 and later. Okay, now using example to do that, if we have this level, incline level and a horizontal level, we have a mass block on this level at point 1, at point 2, at point 3, at point 4. From point 3 to point 4, there is a friction on that surface. It is not smooth as the previous level from 1 to 3. The mass is 10 kilograms. The altitude or the height at this point, at point number 1, is 10 meters. At point number 2, because this is our zero level, we need always to find to pick our zero level. The h, the altitude at point number 2 and point number 3 and 4 is 0 meters. The velocity at this point, point number 1, is 0, but the velocity at point number 2 and 3 is unknown. But the body, after passing a distance, this distance, it will be given later, the body stops because of the friction. So the velocity at point number 4 is 0 meters per second. Does that make sense? Now we know that the mechanical energy is equal always to kinetic energy plus potential energy, and this is for conservative forces. This equation will be right in this case, in this case, and in this case. It will not be right here in point number 4 because we have non-conservative force in this area. We will see that. Okay, at point number 1, if we need to compute the mechanical energy, total mechanical energy, we need to find the kinetic energy at that point and the potential energy also at that point. From the formulas for the kinetic and potential energy, the velocity at that point is 0. So this term will be 0. The kinetic energy at that first point. But the potential energy can be computed by and the value of the potential energy at that point, which is totally the mechanical energy, which is 980 joules. This value will be equal to the mechanical energy at point number 2 and the mechanical energy at point number 3. But it is, or is it equal to the mechanical energy at this point? We will see that. At point number 2, now we need to find the mechanical energy using the kinetic energy formula and the potential energy formula. But the potential energy at that height, which is 0 at this height, because this is our reference, so the potential energy is 0. So all of our mechanical energy is converted to mechanical energy, kinetic energy, I'm sorry. All of our mechanical energy is kinetic energy. So kinetic energy now is equal to 980 joules. From that we can find the velocity. So the velocity is equal to 2 multiplied by the energy divided by 10. 2 multiplied by the energy divided by 10. This is the velocity squared. But the velocity is the root of that, which is 14 meters per second. The velocity for the body at this value in this direction. This is 14 meters per second. We will find that this is the same velocity at all of this surface because we don't have any friction force for this period of time. Okay. For point number 3, we need to compute also mechanical energy, which is the kinetic energy plus the potential energy. But at this height, at point number 3, the potential energy is also 0 because we don't have any height. So again, the mechanical energy is equal to the kinetic energy, and the velocity will be 14 meters per second because they are at the same level. Now let us go to point number 4. This is point number 4 again. We have a friction force. the body is stopped after a period of time, a period of and a distance. Okay, we can find them. Okay, if we need to compute as a conservative force, if we need to find that the mechanical energy using the kinetic energy plus the potential energy, just like that, we can find that the kinetic energy will be equal to half multiplied by the mass multiplied by the velocity, but the body at that point has zero velocity, so the kinetic energy is zero. And the potential energy, because h is zero also at point number 4, it is the same height as point number 3. The potential energy is always zero, is also zero. So the mechanical energy will be equal to 0 plus 0 equal to 0. Where is the energy? We have energy from before, 980 joules. Where this energy gone? Okay. The kinetic energy is 0 because the body is stopped. The potential energy is 0 because it is at the 0 level. Where is our energy? We will see that. The mechanical energy is lost because of the friction, which is not conservative force. So this surface which has a friction does a work, and this work is because the resistance of motion. So all of our mechanical energy are lost in this work, which is the work due to friction force. Friction force, which is non-conservative. You can write W, or work due to friction force, or work in general due to non-conservative forces. Maybe a friction of a surface, or a friction as a resistant of air or water or something like that. So our friction for work is equal to negative value of the magnitude of the mechanical energy. So our friction for or non-conservative forces work is equal to negative 1980 joules. We will see how can we find that. Okay. At point number 3, before the friction surface, we have 980 joules, right? It is kinetic energy. But at point number 4, we have zero energy. After the friction surface and the body is stopped, we don't have kinetic or potential energy. So the initial energy is it is at the point number 3, which is 980, and the final energy is 0. Now the difference or the change in mechanical energy should be constant for conservative forces, and delta E should equal to 0 for conservative forces, but it is not 0 for non-conservative forces. Okay, the change in our energy is equal to E final minus E initial, which is 0 minus 980. So the change in our energy is equal to minus 980 joules, which is the work due to non-conservative forces. It is lost energy, right? Now we can find by using the work formula. The work, we know that the work is equal to force multiplied by the distance by cosine theta. Theta is 0 between our motion and the distance, because the motion in this direction and the force in this direction and the distance in this direction also, but the theta is 180 degrees, so cosine theta will be negative value. So we have the force now in negative value and the work in negative value, because we have the motion in this direction and the force of friction in the opposite direction. We can find the force of friction force for this one, which is equal to the work of friction or non-conservative force divided by the distance. Assume that the distance is 20 meters. Okay, the work is negative 980 and the distance as given 20 meters, then the force will be negative 49 newtons. So we can find the force if we have the distance. Okay, now we suppose that the distance is 20 meters. Okay, now we can find also the friction coefficient mu k, because the body is moving. The friction coefficient is equal to F, which is the friction force, divided by the normal force. We know that the friction force is equal to mu multiplied by the normal force. The normal force, it is the same as mg in magnitude. M is 10, G is 9.8. So so our mu is equal to friction force, which is in magnitude 49, divided by 98, which is the normal force, and the friction coefficient, kinetic friction coefficient, is 0.5 unitless. Okay, it is easy to be computed if we divided our problem. Now again, we have track, this track and this track without any friction with conservative forces, and the mechanical energy is conserved here, but it is not conserved on this path. You need to solve a different examples, use the examples from the book, and you can also solve this one. Thank you.